I'm going to record this uh, meeting. So let me share my screen. Can you see my screen?
Yes.
Okay, good. So in the last 2 weeks, we have discussed functions of complex variable, and I think I've given some examples, so which, to the best of my knowledge, is at least has given us an idea of what a complex variables are. So this week, we shall be looking at sequence and course. So what are they, and how do we deal with them? So please, can you mute your mic?
Okay, sir.
Okay, thank you. So we shall be looking at conscious sequence and sequence in general. So I'm going to. So can you see my screen? So the question is, what is a sequence? So I said a sequence of complex number is a function from the set n of positive integers into C. So what do we mean by set n? For example now, let's say our set is a town, and inside the town, uh, no, let's say our set is buildings inside a town, and the town is C. So there is no how we talk about the town without talking about the buildings inside the town. So the sequence of the building inside the house is more or less like what we call a sequence of complex numbers. So we use the notation Z of n such that n is an element of capital N. That is, each house in that town, 1, 2, 3, 4, are part of the house in the town. So, or more simply say that Z of n to denote to sequence index is not unique. So an example is that if you say that Z of n is equal to n divided by n plus I. So the question is then show that the modulus of Zn minus 1 is equal to 1 all over root n squared plus 1. So how do we do this? Since we know that Z of n is equal to n all over n plus I. So if you are now looking at Zn minus 1, it just be that taking 1 away from this. So we have something like this, n all over n plus I minus 1. And if you perform the numerical operation on it, you find out that you are going to have this, because here the denominator is n plus I, which is a factor. Then n plus I goes here 1 times n, then minus this over 1. It will be n plus I, then it will be n in minus n plus I. By the time you open the bracket, you have this. And this will actually give you Zn minus 1 to equal to minus I over n plus I. Now, if you now take the modulus of this now, so if you take the modulus of this will tend to positive. So we now have n modulus of n plus I. So since I square is equal to minus 1, so meaning that in this place now, we have dealt with this to have this expression. So the question now is, how do we find the modulus of this? N plus I. So I have here as the modulus of this can actually be written as n plus I times n minus I, just like what we call product in algebra. There is something we call difference of two square. If you have a square minus b square, you can write it as a plus b and a minus b. That is what I've done here. So in this case now, if you open this bracket, this will give you n squared minus ni plus ni minus I squared. This will cancel out. You now have this. And since we know that I squared is equal to minus 1, if you replace this with this, then you have what? N squared plus 1. So this is the modulus of n plus I, which we have here. So by the time you replace this with this term now, you have this, which is what we are asked to prove here. Is it clear? Is it clear? Are you ready?
Hello, sir. Can you hear you, sir?
Is it clear?
Yes, sir.
Okay. Shukundi, is it clear?
Yes, sir. Yes, sir. Yes, sir.
Okay, good. So now let's go to the next one. So the next one is Cauchy sequence. So I said a sequence is called a Cauchy sequence if the terms of the sequence eventually all become arbitrarily close to one another. That is, given epsilon greater than 0, there exists n such that if mn greater than n, then modulus of am minus an must less than epsilon. So what I'm trying to say is that when you have Cauchy sequence, the terms in the Cauchy sequence are must arbitrarily very close to each other. For example, now if we find the numerical value of, you perform an operation and you find the numerical value and of two different sets, and you are having 3.12, and you have another one 3.13, you have another one 3.33. You know, they are very close to each other. So this is what we mean by Cauchy sequence, and they have properties. So properties of Cauchy sequence: one, any Cauchy sequence is bounded. That is, they have boundary. They cannot go beyond the boundary. If they move out of that boundary, then there are no more Cauchy sequence. So they are bounded. So any convergent sequence is a Cauchy sequence. That is, any sequence that you compute the value numerically or computationally and they converge to a particular value. So automatically they are referred to as what? Cauchy sequence. So take for example now, this statement now that any convergent sequence is a Cauchy sequence, we can prove it. It's a proof. If A of n tends to beta, then giving epsilon, which is greater than 0, choosing n such that if small n greater than capital N, we have this now, an minus beta, then which is the modulus must be less than the epsilon. Then if mn greater than n, we have this, like we have in the definition. So which is equals to am minus beta modulus must less than or equals to am plus beta modulus plus am minus beta modulus. So this gives us what? 2 epsilon. What this implies that if you open the bracket here now, let's say you perform the operation on this, you are going to have minus 2 beta at the end of the day. I get him now. And this corresponds to, because each of these now, am minus beta is epsilon. So we're now having 2 now. Am minus beta, that is epsilon. Am minus beta, that's another epsilon. The two of them now, they are more or less as 2 plus epsilon, which is 2 epsilon. Is it clear? So the third thing is that a real Cauchy sequence is convergent. That is, any real Cauchy sequence are always convergent. So now let's look at some problem. Say example now, given that Z1 and Z2 are complex variable, then Z1 is equal to X1 plus IY1 and Z2 is equal to X2 plus IY2. Question now, obtain an expression. Please, can you mute? Who is that? So obtain an expression for Z1 plus Z2 and also for the complex conjugate of Z1 plus Z2 and also for the complex conjugate of Z1, Z2 and also for Z1, Z2. So the second question is that if Z is not equal to 0, then it has a complex inverse of this. Show that Z prime, Z inverse is equal to this if Z is equal to A plus IB. Now let's see how we can demystify this problem. Now the first question here is that we should obtain an expression for this. So, excuse me, it's like we have some people waiting to be admitted. Okay, good. So now,
Hello, sir.
yes.
The screen is dark, sir. I can't see. Okay.
Yeah, I'm trying to admit some of the students that are just coming in. Can you see the screen now?
Yes.
Can you see the screen now?
Yes, sir.
Okay, good. So now let's now look at the problem. Can you please, can you mute? Kayode, can you please mute your mic? Okay, good. So now let's look at the problem together now. The first one is that we should look for Z1 plus Z2. So this is Z1 and this is Z2. By the time you perform the normal operation we performed 2 weeks ago, we have this. Now, let's now look at the complex conjugate of this now. By putting a bar across it, we are looking for what we call the complex conjugate. So, meaning that if you look at this now, it is x1 plus x2, then put them in bracket plus I into y1 plus y2. But by the time you put this bar across it, which you call the complex conjugate, this sign positive will change to negative. And that is what gives us this. So we can now rewrite this in terms of the complex variable now. So that will now be z1, then minus I1, which gives us this. Then this is x2 minus I2, which gives us this. So we have obtained an expression for the complex conjugate of z1 plus z2. Now let's look at the product now. If you have z1 times z2, then you look for the complex conjugate. This is z1 and this is z2. If you multiply it together and you expand the bracket, you have this. So z1, s1, s2 minus y1, y2. Because I2, a term here, is minus 1. By the time you put them together, you have this expression for z1, z2. Now, the question now is that if you now look for the complex conjugate of the product of the two complex number. So like I said the other time, that since this is positive, by the time you put the complex conjugate on top of it, this bar, this sign turns to negative. The same thing happened here. This is positive. By the time we put this on it now, it turns to negative. Then you have to expand this now. By the time you expand this, you have something like this. x1, x2 minus I x1, y2 minus I y1, x2, then plus I2, y1, y2. Now, if you look at this now, like in algebra, if you are doing quadratic operations in algebra, in the basic algebra, you can look for like times. What comes to them? Who is that person? So if you look at these two terms now, something comes to them, which is x1. Take it out, you are left with x2, then minus I, then you left with y2. This is in bracket. If you look at these two terms also, something comes to them. There is I here, there is I square here. So if you pick one of the I, it will come out. There is y1 here, there is y1 here. That will show that it comes to them. You can bring it out also. So by the time you take this out, you left with x2 minus, you have I here, which is I y2. So combining them now, look at what is inside the bracket here is the same thing that's inside the bracket here. So you pick one. So you pick one. So this one now, S1 minus I1, which is coming from these two terms, then you pick the only of these, then you give you this. So technically, we have obtained an expression for this term and also for this term. So the last question there is that he said if z is equal to 0, then it has a complex inverse of this. Show that z1, z inverse is equals to a all over a square plus b square minus ib all over a square plus b square. That is, if z is equals to a plus ib. Now let's see how we solve this. So if our z is equals to this, then if you take the inverse of the z now, more or less that you are doing 1 over z. So it will now be 1 all over a plus ib. So now, this is a fractional term. And when you have a fractional term like this, like in SORD, when you are doing SORD analysis in pure mathematics, the denominator here, you can do what we call rationalization. If you rationalize this function now, it is a plus ib, but by the time you want to rationalize it will be a minus ib, then you used to multiply the numerator and denominator. That is why we have a minus ib and a minus ib, multiplying both the numerator and denominator. By the time you perform the operation, 1 times this will give you this. A times this will give you a square. Then I times I will give you I square. And that will be negative because it's negative. I square is equal to minus 1. So that gives you negative times negative will give you positive. Then if b times b, that will give you a b square. So by the time you use this to divide this now, a divided by this, we have this. Then minus ib divided by this, we have this. So that gives us answer to this proof that show that this is equal to this. So if you have any question, you can ask me. The floor is open. If you have any question, you are free to ask.
Hello, sir.
Yes, I'm with you.
Yeah, based on the second example to prove inverse of Z.
Yes.
Then the multiplication you did based on you mentioned sort analysis, and I think it's the same thing as multiplying the numerator and the denominator with the conjugate of Z.
Exactly.
I think it's the same thing. Okay.
Yes, yeah, you are right.
Okay, sir.
Okay.
Thank you.
Now, another question? Another question? It's echo. Please. I think it's coming from Kayode.
Yes, sir. It's actually I told you because I didn't share the video.
I'm
I
sorry.
shared the video.
Kayode, please, I'm sorry. It's not audible.
Okay. I'll try to use the
It's not audible enough.
computer.
Can you hear me, sir?
Okay.
Okay, sir. I said I came late because I didn't check my email early.
You said what? Can you speak louder?
I said I came in late because I didn't check my email at early time.
Okay.
Please, can you give us your WhatsApp number? Okay, it seems you have even given us, but it will help us. It will be very good for us to receive message from WhatsApp.
Okay. Okay. There's no problem with that. I can give out my contact. So you can, let me just put it on the chat. Just a moment.
No, they can be. Hey, it's my life, my balance. Anywhere.